Good afternoon and welcome to this lecture on the staggering implications of epigenetic inheritance. Everyone's heard of epigenetics, that glamorous new branch of bioscience derived from observing DNA through an electron microscope. We've discovered heaps, so it's all been good, but right from the start, the epigeneticists have been trying to tell us that there's more here than meets the eye, and that the implications of epigenetics are nothing short of revolutionary. This all started out where the epigeneticists looked up from their electron microscope and said, well, I can tell you one thing for sure. And the scientific establishment said, no, do not tell us that one thing. We do not want to hear that one thing. And the epigeneticists replying, well, I don't know, it seems pretty obvious. In fact, what it really looks like, no, said the scientific establishment. Your job is merely to observe the phenomena. We will take care of the theoretical side of things. And so over the past 30 years or so, a stalemate has developed in the evolutionary debate, whereby we're not allowed to move forward with these new discoveries that we're making. But of course, we also can't go back to where we were before we knew all this stuff. This stalemate has become so entrenched and so well recognised that in 2016, the British Royal Society held a convention on this very topic. And they introduced their convention with the following sentence. They said, recent advances in epigenetic inheritance and other related fields have prompted a call for a new synthesis, although the issues involved remain hotly contested. Now, hopefully I've set the scene a bit and built up some atmosphere, and in just a second I will go ahead and talk about the most hotly contested of these issues. But then we'll have to take a step back and look at things from a different perspective, just because it all is so mind-boggling. So, the most challenging thing that epigenetics has thrown up for us, the thing that is most difficult for traditional science to accept, is that it very much appears that down at the level of the DNA, all these complicated chemical processes are being directed or organised by some level or aspect of consciousness or intelligence. Whoa. But if we take a step back and look at it from a different perspective, perhaps we need not be so surprised. We are already familiar with many complex processes in the body that require an aspect of consciousness, though we ourselves remain unaware of it. Skin repair, liver function, hormone production, lymph glands, the whole parasympathetic nervous system, and more. Perhaps what we're really saying is that cellular reproduction is a bodily function like any other, perhaps comparable to the immune system in its complexity and mystery. But of course it does emphasise the importance of consciousness and considerably broaden the spectrum of where we expect to find consciousness. And neither of those things traditional science enjoys. Because the reductionist paradigm has never been able to make head or tail of consciousness, consciousness tends to get stuffed away into as small a corner as possible. And establishment science dreads the prospect of consciousness or intelligence becoming central to any scientific explanation. Another fascinating implication of epigenetics has to do with causation. In the old days, we just sort of assumed that genes somehow directly caused the characteristic that they were associated with. But as I say, we've discovered a lot, and so let's consider the following. It's nowadays generally accepted that DNA in the past has expanded by absorbing the genetic material of viruses that it has encountered. And when we consider that the genes from the virus will end up doing different things in our DNA than they were doing for the virus. And now we also know that several genes often combine to contribute towards a single characteristic, which implies that genes from the virus will have to be linked up or coordinated with genes that are already present in the DNA. And it becomes obvious that over time, genes can be deployed in different ways for different ends. And so they're not really the final and efficient cause of anything. They're more like parts from an old transistor radio that you can take out and swap around and use in different configurations. They tune into the signal and they're carrying the message, but they're not the ones writing the song. Now, these sorts of discoveries have been turning the evolutionary debate upside down, and it's not just the evolutionary debate. The whole reductionist paradigm seems to be approaching its use-by date. It can't explain life, it can't explain consciousness, it can't explain quantum mechanics, and these are the things that we are most keen to understand. Now, perhaps I better leave this here for the moment, because I've been told that my lectures tend to go on a bit long and that I try to connect up too much in one go. So I'll leave this as a short and simple but hopefully interesting lecture on the staggering implications of epigenetic inheritance. Thank you.